Yes, obviously I will be recalling some of the concept, because this concept, probability and statistics, the probability and distribution functions are so vast that I will not be able to do justice to complete the syllabus within only 4 or 5 lectures. So I will try my level best. I will start with basic definition of probabilities, and then we'll consider few examples, and then we'll consider the distribution function. Is it okay?
Okay, sir.
Yes, sir.
So probability, the literal meaning of the word probability is finding chance of something. Okay, just a moment. Do you see my screen?
Yes, sir.
Okay. Now, what we are going to do? So we are basically, probability is related to a certain experiment. What is the experiment? Experiment is an act of describing something. So let me write down few terminology which are used in probability. Have you studied probability during your class 12 study or class 10 study? Have you studied it? Huh? Have you studied? You're not responding. Anyway, it is up to you. Experiment is first one. Experiment. Okay, it is an act of describing some phenomena. Act of describing something. For example, you can toss a coin, you can throw a die, you can throw a pair of dice, you can select a card from a pack of 52 cards. You can predict, you can measure the height of a person, you can tell the temperature of the weather at any certain point of the time. So these are the act of describing something. So these things are called the experiment. What is a random experiment? Random experiment is an experiment whose possible outcomes are known to you, but you do not know which outcome is going to happen or going to appear. Random experiment. So an experiment whose all possible outcomes are known to you. Known, but you do not know in a particular performance or in a particular repetition of the experiment which particular outcome is going to happen. Is it okay? But not particular outcome is not known. Okay, so that is a random experiment. For example, if you throw a coin, either it will be head or tail. If you throw two coins together, what will be the possible outcomes? If the experiment is throwing two coins together, what are the possible outcomes?
Sir, head, tail, tail.
Head, tail, head, or tail. So you know what are the possible outcomes, but you are not able to predict which particular outcome going to happen if you throw two coins together. but set of all possible outcomes are known to you. So throwing two coins together, or throwing a single coin, or throwing n coins, or throwing n dice together, eh, or selecting some cards from a pack of cards. So these are all act of random experiment. Okay, what is event? This is very important, because you will be finding probability of certain events. So events, basically this is a subset of sample space. So let me tell you what is sample space. Sample space is set of all possible outcomes. Sample space, this is set of all possible outcomes. जितने भी आउटकम हो सकते हैं एक्सपेरिमेंट के, वो सारे पॉसिबिलिटी को लेके एक सेट बनाएंगे. So set of all possible outcomes. So if you let us consider one example. So if you throw two dices together, what are the all possible outcomes? What are the face values of all possible outcomes? So first dice, the face value may be 1, second die also face value may be 1, or 1 or 2, or 1 or 3, or 1 or 4, so on up to 1 or 6. Then maybe first face value is 2, second face value is 1, or both are 2, or first one is 2, second one is 3, so on up to 2, 6. In this way, 6, 1, 6, 2, up to 6, 6. So these are the all possible fixed values if you throw a pair of dice. So these 36 elements, how many elements are there in this set? If you consider ordered pair, 36 elements are there. So these 36 elements are called the sample space of the experiment of throwing two dice, a pair of dice together. Is that okay?
Yes, sir.
Events is what? This is a basically this is subset of sample space. In mathematical meaning, sample space. The language for describing an event is, an event is a, this is a question. Event will be a question that we ask with regards to a random experiment. Okay, so event will be a question. Event will be a question that we ask, with regard to a random experiment. With regard random experiment. So what is an event? So I can ask, okay, the face value will be, what is the chance that the face value will be 1 1 or 2 2 if you throw a pair of dice together? So this question which we have posed, that is an event. Okay, or if the experiment was throwing two coins together, then what is the chance, what is the probability that one of the face is head, at least one of the face is head? So this question which I have asked, that is an event. Okay, elementary event. What is elementary event? So elementary event is all possible outcomes. हर एक possible outcome को कहते हैं elementary event. Elementary event. This is the event. It is all possible outcomes. All possible outcomes are elementary event. Okay. So for example, if you throw a coin, then head and tail both are elementary event. if you throw a pair of coins, then head, tail head, or tail head, these four are all possible outcomes. These all are elementary events. If you throw a die, then either face value will be 1, 2, 3, 4, 5, or 6. So these 6 are elementary events. Okay. So this is the way you are defining elementary events. Sample phase I have already told you. So now we can define how to measure chance of a certain event or probability of a certain event. So this is called the classical definition of probability. It has some advantages as well as some disadvantages. Basically, till now there are three definitions of probability. How to measure the probability of a certain event that can be described by one of these definitions. First one is classical definition. So if the sample space has finite number of points, sample space में क्या है? What is sample space? Set of all possible outcomes. So if the set of all possible outcomes are finite, then we can use this classical definition of probability to find out the probability of a certain event. So what is the definition? So E word, this E letter, capital E letter is used to denote an experiment. It is an experiment. Okay. S is the corresponding sample space, the set of all possible outcomes, corresponding sample space. Okay. And A is an event. A is an event. Event is what? A question which you ask with regard to an experiment. Is that okay?
Yes, sir.
So these are the related information. So what is the probability of the event to be true or happen? What is the probability of the event A to be true? So what is P of A? So P of A will be number of elementary events favorable to you. So number of elementary events favorable to A by total number of elementary events. Total number of elementary events. Okay. So if first one is M, the number of elementary events favorable to A, if that is M, and if N is total number of elementary events, then M by N is called the probability of the event A, the chance of the event A to be happening. Okay, so let us consider a few examples of this classical definition of probability. So suppose the experiment is throwing a coin or throwing two coins together. E is throwing two coins together. Okay, and S is the all possible outcomes. So what will be the set of all possible outcomes if you throw two coins together? Suppose if head is appearing, I will denote H, and if tail is appearing, I will denote T. So what are the set of all possible outcomes? Head, head, tail, head, and tail. So these are the all possible outcomes. Each of these head, tail, head, or tail are elementary events. Now A is an event. So this will be a question which he will be asking. So what is the chance that the one of the face is head? At least one of the face is head. At least one of the face is head. So what will be the probability of the event A? What is probability of the event A? So at least one of the face is head. So जो चार एलिमेंट्री इवेंट्स है उनमें से कौन से एलिमेंट्री इवेंट्स ए के फेवर में आते हैं, कौन से इवेंट्स में एटलीस्ट वन हेड है?
पहले तीन में
हेड में एटलीस्ट वन हेड है, हेड टेल में एटलीस्ट वन हेड है और टेल हेड में एटलीस्ट वन हेड है. सो नंबर ऑफ एलिमेंट्री इवेंट्स फेवरेबल टू ए, तो तीन ऐसे केसेस है. सो दिस इज 3 बाय total number of elementary events. What are the total number of elementary events? 4. So 3 by 4 is the probability of the event A. If I define another event, what is the, so let B be another event. B is both the face value either head or tail. Both the faces are either head or tail. Then how many elementary events will be in favor of B?
2.
2. Head and head tail. Head and tail. These are the two elementary events will be in favor of B. So probability of the event B will be total number of elementary events in favor of B by total number of elementary events. So this is 2 by 4. So 1 by 2. Okay. So this is called the classical definition of probability. Now this act of experiment, it is not related to throwing coin or tossing coin or throwing dice or selecting a card from a pack of cards. It is not like that. These are the simple way to understand the probability. Their applications are beyond that. Okay. Now, if the size of the sample space is not finite, then we cannot use this definition, is not it? If I ask you, okay, what is the probability that the temperature of the day at 10 a.m. is 13 degree or 14 degree, or at 12 p.m. temperature is, let's say, 30 degree. So the possible temperature, the output is temperature, so it has no finite value. It may be from, suppose in a particular area lowest temperature is recorded as 10 degree and highest temperature is suppose 40 degree. So any value may be from 30 degree to 40 degree. There is no finite number of points. There are infinite number of points, uncountable number of points from 10 to 40. So you cannot use this axiomatic definition of probability. Sorry, this classical definition of probability. In that case, you have to use frequency definition of probability or axiomatic definition of probability. Axiomatic definition of probability is very difficult to make you understand in a single class. You have to consider what is Borel set, that is defined in terms of measure. So I will not be describing that. I'll tell you what is frequency definition of probability. Frequency definition of probability. So this definition is very simple. So what you will be doing? So you already know what is experiment, what is event, what is sample space. So here what you will be doing? You will be repeating the experiment. Let's say n number of times. So repeat the experiment repeat the experiment n number of times. N number of times. Now, in all of these experiments, in all of these repetition, you identify which in which repetition your event has occurred. You have asked a question. You have asked a question. You have posed a question. So while repeating the experiment, you collect all those repetition for which your posed question was true. Okay. So suppose I am tossing a coin. So this is a random experiment because possible outcomes are either head or tail, and I can repeat the experiment any number of times with ideal condition and uniform condition. No changes will be there. If you keep on tossing a coin, this will be random. How many, irrespective of how many times I am repeating the experiment. Okay. Now, what will be the probability? So you are asking a question, okay, what is the probability that the face is head? What is the probability? A is the probability that face is head. Face is head. So how to find out P of A? So again, what you do? You repeat the experiment n number of times, large number of times. N has to be large. Large.
Sir, you are not audible.
Students, am I audible?
Yes, sir.
Yes,
Now
sir.
audible.
Okay, just a moment. इलेक्ट्रिसिटी चला गया था, तब नेट भी चला गया. Okay. Do you see my screen?
Yes, sir.
Okay. So I was discussing the frequency distribution, sorry, frequency definition of probability. So what is this definition? When the sample space is not finite, you cannot use classical definition. In that case, you have to use frequency distribution. It is not like for those experiments whose sample space is not finite, for them only you will be applying frequency definition of probability. It is not like that. You can apply to any experiment if it is applicable to that. So what would be the base? What is the base of this? What is the base of this definition? So you repeat an experiment n number of times. You ask a question, so that will be the event. So what will be the probability of the event? So in each repetition of the experiment, you keep track whether your described event was true or not. If it was true, you keep on counting them. For example, I want to find out if the what is the probability that the face is head while tossing a single coin. So what I'll be doing, I'll be repeating this experiment, tossing a single coin, let's say 10 number of times. And out of 10 number of times, how many times head has appeared? I'll keep a track of that. Okay. So suppose while tossing a single coin 10 times, 6 times head has appeared, or 7 times, let's say, head has appeared. It may, yes or no? हेड हैज अपीयर्ड 7 टाइम्स. जब रिपीटेशन कम करेंगे तो इसमें एनोमली जाएंगे. So let's say 7 number of times head has appeared. But as you keep on increasing this experiment, this repetition, so when you will be repeating the experiment 20 number of times, you will see maybe 12 times head has appeared. As you keep on again repeating the experiment more and more number of times, let's say 1000 times, then you will see around 495 times head has appeared. If you keep repeating more and more number of times, these values they will be fluctuating around a certain value. It will be fluctuating around a certain value. So जिस वैल्यू के अराउंड फ्लक्चुएट होंगे उस वैल्यू को लेंगे. So that will be m, okay, by the total number of repetition n. So m is total number of repetition of the experiment, total number of repetition, and n is that experiment when your event was true. Experiment those experiments, those repetition where a is true. ओके. तो ऐसे करते करते कैसे हम कितने आ रहे हैं 495. सपोज यू आर स्टॉपिंग after repeating the experiment 1000 times. So what will be the probability that the face is head? 495 by 1000. So you will see this will be around 0.2. So you can also use this definition of probability. Okay. So this is frequency definition of probability. And third one is axiomatic. It is a bit difficult to make you understand. Axiomatic definition of probability. All of them will be describing same number or around same number if you can apply all of them to an experiment. I cannot rotate my head. I do not know. I'm suffering from some problem. Anyway, so that was the concepts of probability. simple concepts. What is experiment? What is event? What are the sample spaces? What are the all possible outcomes? How to define probability of a certain event. Now the main thing which is included in the syllabus is called a random variable. Random variable. So you know what is sample space? What is sample space of an experiment?
Those are all possible outcomes.
Set of all possible outcomes of an experiment is called the sample space of that experiment. So a random variable, this is a function. It is a function from sample space to real line. Sample space to real line. This is a clever way to find probability of certain events. Random variable will be defined by the experimenter, because random variable is not unique for a certain experiment. You can define a random variable in any number of ways, but आपको दिखने हैं कि जो आप जो इवेंट की प्रोबेबिलिटी फाइंड करना चाहते हैं या जो पर्टिकुलर रैंडम वेरिएबल आपके एक्सपेरिमेंट के लिए ठीक ठाक होगा, आप वैसे उसको डिफाइन करेंगे. सो इट विल बी डिपेंडिंग ऑन द एक्सपेरिमेंटर and his knowledge which particular random variable to consider. So first let us understand what is random variable, then I will be talking about some instances. So it is a function from sample space. So sample space is capital S to real line. It is not denoted as f. Okay, so basically normally functions are written in terms of f, but in probability and statistics random variable is denoted by the word capital X or capital Y or capital Z. These words, these symbols are used, these letters are used. So I'll write here capital X. So capital X is a random variable from sample space to real line. हर एक sample space के element को real line से associate करेंगे. For example, if you toss two coins together, or let's say you are tossing a single coin, so what is possible outcomes? Head and tail. It's not it. So you can define one random variable x1. So x1 is a random variable which is defined as x of small x. Small x is elementary event in S. So small x is either head or tail. Small x is elementary event, an element of the sample space. So all possible outcomes. So that is small x. So x1 of S you can define, let's say 5 if x is head, and you can define x1 of x, small x is equals to 10 or any number if x is tail. Or you can define x1 of s is 0 if x is head, x1 of x is 1 if x is tail. So you can define any number. So remember, it is a function whose input is elementary events and what is output? Real number. Is that okay?
Yes, sir.
Yes, sir.
Okay. So let us suppose we are tossing two coins together. So experiment is tossing two coins. Just a minute. So if you are tossing two coins together, then what is the sample space? S is head,
HT,
head
TH,
tail,
TT.
tail head, and tail tail. So you can define a random variable that denotes, so x of x is equals to, so I am defining a random variable x from S to R as follows: x of an event, so output of an event is number of heads appearing in that event, number of head appearing in small x. Small x is elementary event. Okay, so what is x of capital X of small x? What is the image of the event x? Is number of head appearing in x. So what if this is the function, this is the way I am defining the random variable. What is x of head? 2. What is x of head tail and tail head? 1. What is x of tail tail? 0. So this is the way I have defined a random variable. X of s is number of head appearing in the event x. Okay, so this is one way I can define a random variable. I can define random variable in several other way. I can define x of head equals to 10, x of head tail equals to 20, x of tail head equals 35, x of tail tail equals to 100. So second one is also a random variable. I have assigned each event, each elementary event to some real number. But second one is not of that much use because we cannot, we do not see any pattern, we do not see any physical description of that random variable. But first one, which I have used, that can be used to find out probability of some events. Okay, so what is the probability that the random variable x is taking value 0? So this is called an event. Event is, you will be asking what is the random variable, what is the probability that the random variable x is obtaining certain real number. So x of x equals to a, this is an event, or x less than equals to a, that is an event. Okay, so x equals to a or x less than equals to a, or x a less than equals to x less than equals to b, these all are events, these all are events. What is first one? The first event x equals to a is all those elementary events belong to capital S such that x of small s equals to a. So you see, you are looking for those elementary events, you are looking for those elementary events, small x, sorry, for which random variable is taking the value a. So it is a collection, this is a subset of sample space. Second one is x less than equals to a. What is that? All those elementary events belonging to the sample space such that random variable, the random variable capital X assuming the value at small x, that assumed value is less than equals to a. What is this event? A less than equals to capital X less than equals to capital B. All those elementary events in the sample spaces such that x of x will be lying between a and b. Random variable capital X will be assuming the values between a and b for the elementary events small x. So it will be a less than equals to small x, a less than equals to x of x less than equals to b. So that is the event, third event. So each of these, x equals to a, capital X less than equals to a, small a less than equals to capital X less than equals to small b, these all are events. Okay, these all are events. So what is the probability? So in tossing two points together and describing the random variable in this way. So this particular random variable I am talking about. So what is the probability that the random variable x is assuming the value 0? So you see, we are finding probability of some event. It is probability of some event. This line which I have written, this is probability of some event. Probability of some events. So what is the probability that the random variable x is assuming the value 0? तो 0 कौन सी इवेंट के लिए है? You have a sample space जिसमें 4 एलिमेंट्स थे, हेड हेड, हेड टेल, टेल हेड एंड टेल टेल. तो 0 कौन सी इवेंट्स के लिए आपको मिला? कौन सी एलिमेंटरी इवेंट्स 0 से एसोसिएटेड है?
टेल टेल के लिए सर.
Tel. So only one event. So 1 by total number of elementary events. So total number of elementary events are 4. So 1 by 4. What is the probability that a random variable x is assuming the value 2? So 2 कब हुआ था?
हेडेड पे.
हेड के लिए number of heads appearing in the event. So 2 was assumed by that event. Which event? Only head. So how many such events are there? Only one event. So 1 by 4. Okay. What is probability of x equals to 1? So random variable x assumed the value 1 for which events? Tail head and head tail. So 2 events were there. So 2 by 4. Total number of events 2 by 4. So if you consider tossing 2 points together, then that random variable x has probability mass function or probability distribution as follows. So capital X is the random variable which assumes the value 0, 1, 2, and what is the probability of that? Random variable x in that experiment, tossing 2 points together and defining random variable by number of head appearing in that event. Okay, so what are the possible output of the random variable? 0, 1, 2, and what are the corresponding probabilities? 0 की probability कितने हैं?
1 by 4.
1 by 4, then
1 by
1 की
4.
probability है 2 by 4, then 2 की probability है 1 by 4. So जो अभी मैंने लिखा, this is called the probability distribution. Later I will be telling you, we will be considering, basically that is what we are going to consider. Probability distribution for discrete random variable and continuous random variable. Random variable दो type के होते हैं. I will be describing that also. So this is called probability distribution of that random variable. Probability distribution, or let me use that single term which will be suitable for you. Probability mass function. Probability mass function. Why mass? Mass will be used for discrete random variable, and density, probability density function will be used, that terminology will be used for continuous random variable. So right now the random variable which we have considered is discrete because random variable is assuming a countable number of points, basically a finite number of points, 0, 1 and 2. So if the random variable assume a finite or countable number of points, then that random variable will be called discrete random variable. And you also have given, so mass points are 0, 1, 2. These are the mass point, the random variable assuming the values, and we also have given the corresponding masses. How much, what is the weightage for 0, what is the weightage for 1, what is the weightage for 2. So that is given by P of x. So this is the way we are describing the probability mass function of a discrete random variable. Now sum of these Px, sum of the Px is going to be 1. If you add 1 by 4 plus 2 by 4 plus 1 by 4, that is going to be 1, and it is true for any event. If you add all the possible outcomes of a random variable in discrete case, that is going to be 1. If you integrate a continuous random variable defined in an interval, that is going to be 1. So ये हम लोग और भी डिस्कस करेंगे डिटेल्स में. Okay, so this is how the random variable is used. Another experiment we will be considering, what is the need of random variable. So any experiment, the experimenter decides which random variable is of interest to him. For example, if an experiment consists of tossing a die or finding out the number of dead, so if you are tossing a die and your aim is to find out which number has appeared, what is the upturned face value. So E is tossing a single coin. E is tossing a single coin. Okay, not tossing a single coin, tossing a throwing a die. E is throwing a die. Another example. Okay, throwing a die. Okay, now if your concern is to find out which face value has appeared, it will be either from 1 to 6. So how you will define a random variable? X of small x will be 1 to 1 or 2 or 3 up to 6. 1 of, so x of x will be x itself. What is x? X is 1, 2, 3, 4, 5, 6. So your experiment is throwing a die, and if your concern is find out the upturned face value, then you will be defining a random variable capital X of small x is equals to small x, where small x is 1, 2, 3, 4, 5, 6, or a pair die. Okay, then this random variable can be used to find out the probability of certain events. But if your concern is whether the upturned face value is even or odd, then how do you define random variable? You only want to check, or you only want to see if the upturned face value is even or odd. Then how do you define a random variable? So then you will be defining x of x, capital X of small x will be, you can associate some value, let's say 0 if x is even. फेस वैल्यू अगर इवन है तो उसको 0 से एसोसिएट किया, एंड इफ फेस वैल्यू इज ऑड देन आई विल बी एसोसिएट दैट इवेंट टू 1. So if x is odd, okay, now I can find out the probability. So what is the probability that the random variable x is assuming the value 0? So 0 कब होंगे? 3 केसेस में होंगे,
3 by
2,
6.
4 and 6. And what are the total number of elementary events? 6. So 3 by 6. 3 by 6. That is the probability. What is the probability that the random variable is assuming the value 1? So this is probability that the random variable x is assuming the value 1 will be, you have to look which events are associated with 1. So x is odd. How many values are odd, face values are odd, 3 face values are odd, and they are associated to 1. So 3 by total number of face values. So 6. Okay. So this is the way random variable is used to describe the probability of certain events. Okay. So I'll be stopping the discussion at this point. So let me summarize. We have briefly described what is the basic concepts of probability and what is random variable. Now how to define a random variable. Okay. So random variable, how you define that is up to you. But whether that random variable will be useful or not, it will be depending on your experience, how you are choosing the random variable. Now we are going to consider some of the random variables and their density function and distribution function, and we are going to study them in details. So first, random variable will be classified into two groups. One will be continuous random variable and another will be discrete random variable. If a random variable assumes countable or finite number of values, if जो रेंज होंगे रैंडम वेरिएबल के उसमें अगर फाइनाइट या काउंटेबल नंबर ऑफ पॉइंट्स हैं तो दैट विल बी discrete random variable, or if the random variable assumes all value in a certain interval, then it will be a continuous random variable. For example, predicting temperature of weather, rainfall in a particular date. So they will be assuming all values in an interval. So in that case, we'll have to consider continuous random variable. And we are going to consider few important random density functions with regards to discrete random variable and continuous random variable. Discrete case में हम consider करेंगे binomial, then Poisson, then discrete uniform distribution, और continuous case में हम लोग consider करेंगे normal distribution को और uniform distribution को, and we will be learning about their mean, variance, what is the meaning of mean, what is the meaning of variance, that also we are going to learn. Okay, so this will be our aim in next few classes. Any doubts so far?
No, sir.
Okay, so if you have any doubts, you can ask me. If no doubt is there, then you may leave the class.